So for part of our project, we will be rotating a globe, and we need the globe to rotate between 1500 and 1800 revolutions per minute. Additionally, we need to do so with a motor that can actually handle 1 to 2 amps between 12 volts to 24 volts DC. So a significant amount of power. So it just has to vary roughly between 1500 to 1800 revolutions per minute. And so given that, we don't want a microcontroller to control it. Instead, we just want to know exactly the correct voltage to send to that motor to get it to turn at that rate, given the load it's going to have on it, the load being the spinning ring. So to do this, we are going to order the parts, the motor, build everything together, and then use a variable power supply, such as this one, to test what voltage we actually need. Once we know that, we can order a voltage regulator accordingly. So the test I'm going to show now is how we can use a variable power supply, such as this one, to control a motor. So right now, the voltage supply is currently capped at 0.2 of a volt, and you can see as I crank it up, the motor is starting to rotate relatively slowly. But as I increase it, the motor is rotating quicker and quicker. If you go up to 9 volts, which is what we used in class with a PWM of 255, the motor is rotating quite quickly. So again, what we intend to do is we intend to purchase the motor we need and then use this variable power supply to actually see to determine what the proper voltage is to send to the motor to get it to rotate between 1500 and 1800 revolutions per minute. And during another presentation we can explain why we have that exact number, 1500 to 1800.